first slide was with the logo of my company and StartSmart and my name. Well, my name is Andri Laidre. By education, I am a mechanical engineer. I studied product development in Tallinn University of Technology. I also studied as a guest student in Arts Academy, and I studied product design there. And then I heard today that there are some people from Finland here today, and just wanted to say moro, because I also studied in Finland in the University of Technology. And today I'm going to speak about some experience that I have gained during the many projects that I have been involved with. And to start with Finnish people, then maybe the first advice I can give you, or the note that I have for you, is that there's no point to rush in projects. And this is what I learned during my studies in Finland. I studied in Finland for 1 year, and we had a group of 8 people, and we had to design a transformable bicycle. We had 1 year, and in the end of the year we had to have the real prototype ready. When we started, you can see a part of this bicycle here. Thank you. When we started the project, then we had a lot of meetings, a lot of planning, and a lot of coffee breaks. Finnish people love coffee. And there was a coffee break every 45 minutes. There were lunch breaks, snack breaks, and always breaks and breaks. And I was thinking, with this kind of speed, we are not getting this product ready. In the end, it turned out that everything turned out really good. And the reason for this, I think, was coffee breaks. Because if you have a break, then you restart your brain, you look at your problems at a different angle, you have a discussion with your teammates, and it saves you a lot of time. And I think that in Estonia, when I look around, then when Estonian companies or engineers are given a task to solve something, then they really go really deep into the problem-solving phase, and they put in a lot of hours, but actually they should make the breaks as well, and this means that they will win some time in the end. So here's some pictures of the project I have been involved with. Right after I finished the university, I founded a company called Flydog, and for 5 years we offered product development services in Estonia. At the moment, I am developing my own product. We are doing sea monitoring systems. I'm also a co-founder of a new startup called Velodrome that is developing a smart bicycle light. And once a week, I teach in Estonian Realkool. It's a high school in Estonia. I teach product development and design to high school students. The first project that I will speak about is a wind turbine that we designed for a company called Goliath. They had the idea, and our task was to develop the first prototype. This is the turbine, and the diameter of this turbine is 4 meters. You can see an electrical engineer, Ants Kallaste, standing here. So it's a big monster. This is a video. Apparently it's not working at the moment, but that's okay. And when we started to design it, then I was really terrified, because I was like 3 years out of the university. I was not so experienced, and it's a really tough challenge to start with, because the outer ring contains the magnets, and the inner ring contains the coils, and the outer ring is moving, and the distance between the two parts is only about 5 millimeters. And I think that the note I can give you here is that when you start a project, then you have to have a really good specification. Take time to really write down what the product is expected to do, what are the parameters, what are the constraints. Here, after the prototype was built, there were some minor issues, and later when I look back, then I see that actually the fault of this was because the specification had some minor errors, and we should have put even more time in making the right specification. Here is a project that we did for a Norwegian company. The project name was Walkix, and we were involved in a project where we had to design a walking robot. When people have strokes, then it's really common that they get paralyzed and half of their body will not move. And after the accident, they are being taught to walk again. And the idea of this project was to build a walking robot where the people is harnessed to, and the robot will then manipulate the man's legs, and from this mechanical movement the brain relearns how to walk again. And our task was to build the harness that holds the person. And the note I can give here is that when you do a new product, expect a lot of prototyping. Usually when an engineer is given a task to develop a new product, then they sit down, they have some sketches, then they go to the computer, make the drawings, send the drawings to the manufacturers, and then they have the real product in the end. Here it was not like that, because when we wrote down the specification, we knew exactly what is the weight of the person this harness has to hold and so on, but there was one line that said it has to be comfortable. But how do you design something in the computer that has to be comfortable? It's a really tricky parameter. So what we did was reverse engineering. We hired one girl that was studying textile engineering, and we started to do prototypes. And we did around 5 prototypes. We learned from each prototype, altered the design, and then in the end we got the result that really was comfortable to the person that was in this harness, because the person literally has to be held in this harness for around 50 minutes. And here you can see that we did a lot of benchmarking, because if you're doing a mechanical project, then you can be sure that these problems that you are tackling at the moment have been solved everywhere somewhere else. And for example, we tried some parachuting harnesses, some kite surfing, some rock climbing, some working harnesses, and as I was the lightest guy in our team, I was put into this construction, and we were testing all these harnesses, which are comfortable, which are not so comfortable. Everyone has their pros and cons, and we learned really a lot of from other projects or products that are not for this use, but they are really similar to this. For 3 years I have been working with a Swedish company called Skagergardstunneln, and they are producing wooden heated hot tubs. And some things that I have learned from this company, I think they have been the best teachers for me, because for the 3 years I have been worked with them, I've been seeing how the design works, how they communicate to the manufacturers, suppliers, how they get their product to the market, and so on. And the point here is that if you get the prototype finished and you get the product to the market, then actually the really hard work starts, because then you start to optimize. Because when you do a prototype, then it's never an ideal product. And at the moment, we started 3 years ago when we had the first idea how to do it. Then 1.5 years ago, we did the first prototype. A year ago, the product was launched to the market. And even now, every 2 weeks, we have meetings where we discuss what we can change in this product, how we can make the assembly quicker, how we can change the material so they can be cheaper to produce or they would be just better, where we can find better suppliers and so on. Today morning I had a Skype discussion with the owner of this company, and we were speaking about this presentation, and I asked that what is his biggest learning, and he said that he just read a book, Toyota Way, and it turns out how Toyota makes their new cars. At first, when they design the concept and the first rough models, then they have a group of engineers, and then in the end, when they get to design the details, they triple the amount of engineers, because details are what take the most of time when you're designing something. In this product, the core value is the stove that is under the bath, so there is nothing inside the water, so the bath is really clean. And when we started, we didn't have any experience with designing stoves, and in the end we made 8 prototypes. The 8th one was what we were looking for. It worked because at first we didn't involve a guy who knows something about thermodynamics. When we had done around 4 prototypes, then we realized that okay, we need some extra help. We went to the university and basically hired one thermodynamics engineer who told us all these parameters, what is the diameter of the smoke tube and what is the surface area of the stove and so on. And after involving a specialist to the team, we were really going forward much more quicker. I have seen how my clients really struggles with finding the best suppliers for the components. For example, the bath itself is done in Estonia. The smoke pipes come from Germany. The wood comes from Finland. The stoves come from Lithuania. Some covers and extra parts come from Russia. So the chain list is really, really, really big. And my client really puts a lot of effort in finding the best suppliers. He started out with finding the cheapest suppliers, but in the end, when you're cheap and you're not so trustworthy, then when you have a delay from one supplier, that means that you cannot assemble the whole bath and your clients have to be waiting for your product, which is never good. So at the moment, he finds that in the end, to make more money is not to find the cheapest suppliers, but the best suppliers who you can really rely on. This is CAD renderings of 2 versions of the baths. The one on the left was designed by me. The owner of the company had a really good idea what he wanted to achieve. I made the model. We CNC'd the whole product. We made the molds. We had the first prototypes ready. And then we went to the factory and looked at the product, and we saw that something is not correct. It looked pretty okay in the computer, but in real life it didn't turn out very beautiful. And then we involved a designer, and it took him, I know, maybe only 2 weeks. He had the computer model ready, and we did the whole manufacturing process again. And when the VAT finally came out, then it was just perfect. So you really have to trust the designers, and you have to really bring them early on to your projects. So this is the product that I have been working for 1.5 years now. This is my own product. It's a sea monitoring systems. At the moment, when you want to get information from the sea environment, then you have to take a big ship, go to the sea, make the one measurement, come back. The running costs of a ship per 1 day can cost you like 4,000 euros, 6,000 euros, 7,000 euros. It depends on the ship. So it's really expensive to get data from the sea environment. And when you take a ship, go to the sea, come back, then you get only one measurement. You don't know what was the situation in the sea 3 hours before or 3 hours later. So we designed a platform that you can deploy into one location, and it will make measurements every 3 hours. It will send the data over GPRS to our server, where our clients then can use our interface, where they can download the data and view the data. And we have sensors that are not produced by ourselves, and we lower them to the bottom of the sea, winch back up again, and from every centimeter we take measurements. So we really see, this is for example a graph of temperature. We see that there is colder in the bottom and warmer on top, and if you look at the time, then we see how this changes. We measure temperature, salinity, oxygen, and so on. And here are some notes that I have from my own experience, that customers is the key element. As Dan said, that every project that you start, you have a customer in mind, or you have already a contract with the customer. And this is our own experience as well. This is the first product, and it was finally deployed 3 weeks ago in Finland. So we have a paying customer from Finland. And why it's good to have customers when you're developing your first product. First, I think that when you're a startup, a lot of you are looking for investors. Investors love when you have already paying customers. When you have a real customer, then you can really learn about user needs. When we started the project and we were discussing what we can offer to our clients, then we had really great ideas. We can do this, we can do that, when we were really excited. And we saw that actually the clients were not interested in all these whistles and bells. They had their own needs. So we altered the designs according to their needs. The clients are the best debuggers ever. For example, when we had our user interface ready, we made a live demo over Skype with our Finnish customers, and they started to ask questions. How do I do this? How do I do that? I don't understand this. And I was thinking that, are you stupid or what? Because when we have planned it, we thought that everything's really logical. But in the end, when the user starts to use it, then they will not find it that simple. And we learned a lot from that experience. We changed the design so that it would be more intuitive. I think that the next speaker can speak about this better. To have real clients from the day one, it's good because you have revenues. In our case, at the moment, we have sold 2 systems, and with that money, basically we can cover our product development costs. So we will be on ground zero at the end of the year, which is really, really good. At the moment, we haven't involved any investors. And finally, if you have a working prototype that is used by a customer, it's really good for a reference. Because we were in marine, they're like trade shows, and we were introducing our product before we had this product ready, and everybody asks, will it work? When you put something into the sea, something breaks, then you have to take a ship and go and repair it. Have you any use cases? Will it really work? How can we trust you? So it was really difficult to earn this trust. Luckily, our first customers, they took the risk, and they let us do the first product for them. Something about teamwork. In Flydog, there are actually only 2 people, my partner Karl Vene and I, But as we are mechanical engineers and this product involves electronics, programming, server programming, user interface, then we had to hire specialists to our team. And as we had to really in a short notice have to move out of our office, then we landed in my partner's garage. So this is like really back to the roots, like Apple started. We are working in a garage when we were assembling the first prototype. And about teamwork, what is the word in English when you work over long distances, when you're not in the same room? Remote working, yeah. I think you can manage, but I think if you're working with a team in the same room, it's always better. And our programmer lives in Tartu, it's in South Estonia, and for the first half years we worked remotely. And at one point we saw that it's not as efficient as we needed to be. And basically, in the end, for 2 months, he worked in Tallinn together with the rest of the team, and really the project leaped on forward really quickly. Something about their process. We have been thought about and said about that we are a startup, but actually our journey started already in 2007 when we started the company. In 2008, one of my partners designed an ice buoy for Marine Administrative Institute. There are around 30 buoys like this in the waters of Estonia at the moment. This is the first experience we got from sea environment. Then in 2007, we had a project for Estonian Marine Systems Institute where we had to make a product that is similar to our product at the moment. And this was not our own product, but this was just offered as a service to them to engineer this product. And so step by step, we gathered some experience, and at one point then we saw that actually we have the experience to do something in the sea environment, and we see that there's a need for this kind of technologies. And so we started to concentrate solely on developing our own project. It was not like one morning you wake up and you decide that let's start something new. It's a really organic and logical journey. When we designed our product, then we had to design our own controller. As Dan said, that we started out with looking for controllers that would suit our needs, but there was not any on the market, so we had to design one for ourselves. And when we did it, then we did it bigger and more complex than actually was needed by our product, because we didn't know where we end up in the end of the day. And we always asked questions, what if we can use our technology here or there, or there's so many other customers that would need similar technology. And here's a great example. A month ago, we did the project together with one Estonian company called LDI. They are developing optical oil monitoring sensors, these green sensors here. And they can detect if there is any oil in the water. So we had our controller, we hooked it up with their sensors, and now on Linnahalli Kai, it's a port in Tallinn, there's the sensor, and when it detects oil, it will send text messages and emails to the environment authorities. So we see that actually, based on the technology that we developed, we can start to offer not only sea monitoring systems, but environment monitoring systems. So we can basically spread hundreds of sensors over the capital of Estonia, for example. We can measure temperature, how clean is the air, how much pollution or noise the city has in various locations. We can send the data to our data center, and we can then make websites where we can publish this data. Sorry. And here you can see we are measuring if the water is clean and what is the water and air temperature. So always have in mind the question, what if we can find some other ways to have my technology working. The last slide I have is about mistakes. During the 6 years that I have been doing the projects, I have made a lot of mistakes. As Dan said, the number of pi actually is a really great number. It's really difficult to estimate how much hours, how many hours a project will take to design. Usually, we always underestimate it. We always, when we speak to clients, then we add some hours, but we usually spend them up. It's one of the mistakes that we always do, and I think that we always will make. But I think that mistakes are not bad. I spoke to one business angel in Estonia some time ago, and he said that mistakes are really good because from his experience, a couple of projects that he had on his table were waiting for his yes. At the time, he didn't have the time or the money, and maybe half years went by, and he saw that actually it was really good because it would have been a wrong step for him. Because if you act really quickly, then yeah, you can go in the wrong direction. But if you have more time, then in the end you will see the organic process that it will guide you to the right direction. So this was the overview and some notes of my experience that I have gained during developing physical products.
Questions?
Oh, do we have the video now? Oh, yes. This was really terrifying when I saw for the first time when it was rotating, because if this machine would have fallen to the ground, then it would have gone through 4 or 5 walls and killed some people maybe. This is a wind turbine. The idea is that usually the magnets are inside and are rotating. Here the magnets are outside and rotating, and the stator is in the inside. And when you have the magnets on a really big diameter, then the speed here is a lot more quicker than in here. And so when you want to have the same efficiency, then the turbine doesn't have to rotate as fast as the conventional ones. So there we gain this extra power.
Yes.
Maybe a little bit off topic, but in that case, are you powering the generator to use as motor, or is it powered by anything else?
At the moment, this was a test platform. There are no blades, as you can see here, and it's hooked on a motor that will give it the rotation. And it was just to see then at what speeds how much power you get out.
Hi, I want to ask about a connection to Estonia and how you feel that how good place is Estonia for that kind of development work? Do we have a network which is good enough, like for workshops and labs to create the prototypes? And the other thing is how the other companies from other countries see Estonia as a reliable a partner for development of products, as I think Estonia is not very much known about our physical stuff we around the world.
Speaking about building prototypes, then at the moment the situation is not very good. I think we have done, I think that half of our projects have been prototypes, that we design a prototype and then from that prototype the clients move on by themselves. So we have to design the prototype and organize the manufacturing of the prototype. And in Estonia there are not so many proto labs yet that we can use to have our ideas put into steel. And it's always that we have to use our personal connections, because when you do a prototype then you have really small quantities. Usually when we send out the drawings and can we get the price offer, then they ask, okay, how many? 100, 200, and we say no, one. But this is really expensive, and for the companies that are producers, then it doesn't pay them very much. So at the moment I see that it is a problem, and I would really like to see proto labs coming up.
There's a question there.
Thanks. I think I missed. You were saying about the fact when you built the sea monitoring system that you can remotely control and you can make it go down and take samples. And you said that on the fair it was hard to convince people who had never seen such a thing working that how is it going to be reliable and so on. So how did you manage to make the first sale? What were the arguments that actually won the customer on your side?
Can you please show my slides on the screen? No? Okay, not a problem. As I said, that the journey was 4 or 5 years. We started in 2007, and in 2009 we did a similar project to Estonian Marine Systems Institute, where we took a profiling system of an Italian company and basically we made it float on the sea, and we then made the system working. And the client from the Marine Systems Institute, a professor called Urmas Lips, is a really fanatic. He likes the product, and he has gone all over the world to seminars, and he has made many discoveries based on our technologies, because there has not been that kind of information available before. And so he has really advertised us, and he actually introduced our Finnish clients to us, and he said that, okay, I have experience with them, you have the same need for this kind of data, talk to these guys. And then when they contacted us, then the first thing we did is that we went to Finland. We sat down with them, we showed our portfolio, what we have done. I think when we show a wind turbine, then that shows that, okay, we know how to manipulate steel. So this won their trust.
Wait for a mic.
Did you use any? Did you cooperate or use any other kind of design or R&D companies? That how much did you use subcontractors besides machining?
We totally outsourced electronics, hardware programming, and server programming. And what we have in-house is hardware development, electronics hardware development. But we outsourced all the programming because this is not what we are good at. We are trying to get into this area because we have to understand what's going on, but we can never do it by ourselves, which is a really good thing, because as the next thing that we want to do is to start to develop the sensor fleet management system, and this is mostly all about programming and electronics. And as we do not know how to do that ourselves, that gives us more time to do more business development. Otherwise we would really go into engineering, but actually we have to deal more with business development.
Hi, Andri. I'm Leo from Estonian Inventors Association. First of all, I thank you for talk. It's been really good to see some real stuff you're doing. I'd like to ask, when you assemble your things, do you do mainly on this side, or you do some in Finland, or how do you decide where is a better place to do?
The buoy that we have weighs around 450 kilos. Compared to the buoys that we have out on the sea, it's a really small buoy. And our task, or one of our, when I was speaking about setting up the specification, then we set up the specification that we have to have it fitting on a car trailer. So basically, we made it from 2 parts. We put it on a car trailer, and we went to Finland. We assembled it in half an hour on the pier. Then it was lifted with a crane to the ship, and then it was shipped to the right location. But as we are not a manufacturing company ourselves, and we never have had the plans to have our own tooling, then we mostly subcontract all the parts, but we assemble them ourselves.
Can you say which side is better, like technically, for inventors? Say, is it Finland, Estonia? Where are advantages for guys? Can you advise some inventors perhaps where to assemble the bits and do?
Well,
any recommendations?
when you assemble the parts, then you don't actually need much tooling. You need only a garage that I showed a picture of where we are working at the moment. It's not pretty, but it's creative environment. But in that sense, it doesn't matter. You need only a garage and some tooling and some manpower to assemble things.
Okay, thank you.
The first row.
Yep.
Hey, thanks. It was a great presentation, and your portfolio was pretty diverse and really different projects from all sorts of industries. It's always interesting to know how do you find your customers, or how do they find you? Probably, I think, because the portfolio was not so large, still it's just personal relations behind them mostly.
Yeah.
And when customers approach you, then what is the success rate? How many people have to approach you, and how many of them actually become your customers? It's like, what is the ratio between people you have to listen to and say, yeah, it's a nice idea, but we're gonna do it?
During the 5 years, we didn't do any marketing because we had the project, and then we had the mouth of word. One project led to another project. We got the client from Norway. That client suggested us to another client in Norway, because the price difference of an engineer in Estonia and Norway is really huge. And as we did a good job, then we didn't have to market ourselves that much. But we started out doing projects in Estonia, and we found it really difficult, because we wanted to do really cool projects. But there are not many companies in Estonia that are doing cool stuff. So we were struggling a lot actually to find the work. And when we had the project, then there were some times where the project ended and you didn't have another client waiting for you. So you had a month or two when you had to wait. And this is why we decided that we have to start designing our own product, because you put the effort in once, and then it can pay you back in 5 years constantly.
Hello. Actually, I have one question regarding, you mentioned a key point as you didn't use any investors. So how you are managing your bread and butter? Because I can see a lot of, even though you are mentioned as you are making it in a garage, but there are a lot of manpower effort as well as the tools and utilities you needed. So how you are managing without any investors? Are you taking any bank loan or something?
As we are a small company, then we deployed the first system in Finland 3 weeks ago, and we will deploy one system in Estonia in September. And for example, we have to use a sensor that was specified by the clients, and the sensor costs around 20,000 euros, and we don't have money for that. So we asked for a loan for that. But as we have won a tender and we have the agreement with the university who made the tender, we can show that agreement to the bank or to some other who gives out loans, and then it's a guarantee. Then they will give you the money. Then in that way, if you have the paying customers, then it is never a problem to find the money to the project. But when we started out, then we used our own money that we had gathered during the engineering service times. We had some discussions really early on with investors, but we didn't have a really clear idea what we want to do, so they were not really convinced. And now we are already in a better position because we will have the proof of concepts on the sea. And if we want to really upscale and we need more money to hire sales team and so on, then involving an investor will really speed our process. So we are not against investors.
One question from there.
I want to ask a question about the oil monitoring system, how efficient it is, and also how are you guys looking towards Africa in terms of B2B strategy of the oil monitoring system?
The oil monitoring system, we had the idea. We decided together with the other company who manufactures the sensors that we will do a pilot or a demonstration project. It took us 2 weeks to integrate the two systems and have it working. The sensors that this Estonian company called LDI Laser Diagnostic Instruments is using are, well, they claim that they are the best on the market. They are 10 times more energy efficient. They are 10 times more lightweight. It weighs only around 2 kilos, so you can really use small buoys where you can attach them and so on. So in that sense, their technology is really good. And their sensors can be working 30 centimeters above the water or 10 meters. So you can install them on cranes or on decks. And so at the moment we are looking for ports who have problems because they have a lot of ship traffic. And when there is a ship that is leaking oil, then you cannot tell which ship is leaking because all the ships say that this is not my oil, and you cannot find these ships. But if you make like this oil monitoring system that sends out alarm as soon as it sees the oil, and at the same time we are planning on our web platform to have this AIS system that's basically ship location like tracker. We can really see what ships were around the sensor on the time when the alarm went off. So we can really see that the ship that is causing problems is one of these 5 ships, and then you can really start to investigate which one of them is the guilty one.
Thank you very much.
Thank you.